This is Accelerated Geometry, Section 8.3, Part 1. This deals with two area formulas, the area of a circle and the area of a regular polygon. Now, the area of a circle, some of you may even know. You might be blurting it out right now as you're watching this video. But the question is, where did that formula come from? So that's what I'm going to try to do today, explain where the area of a circle formula came from. So we're going to start with a circle. Then you fold that circle in half. You fold that in half again, that in half again, that in half again. And when you open it up, your circle now has 16 slices to it. Before we go any further, I'm going to take this marker and I'm going to go around here in green just to remind us that that is the circumference of the circle. So the circumference of a circle is 2 pi r. Now, after you cut out those 16 slices of your circle, you're going to put them with a peak going down, and then next to it the peak going up, the peak going down and up and down and up and so on, until you have all these 16 pieces taped together. As you do that, you'll find out that the green ends up here, and there's green up here, and green here, and here, and here, because that circumference, that green circumference, is being placed above and below, like that. So it kind of now looks like a parallelogram. So I kind of have changed my circle. So the area of that circle, I now think, is equal to the area of that kind of parallelogram that I have. So now I think about a parallelogram. The area of a parallelogram, we've talked about that, is the base times the height. This would be its base, and a perpendicular distance from one base to the other would be considered the height. Okay, now, what is this base? All of the green stuff was 2 pi r, the whole circumference. But as I did this, you can see that there's 8 pieces of the circumference on top, and there's 8 pieces of the circumference on the bottom. So this base is really half of the circumference. So that is half of 2 pi r, and half of 2 pi r would be pi r. So I can come back here and say the base is pi r. I'm going to multiply that times the height. Now look at this height, the perpendicular distance between the two bases. It seems to be going right down the middle of that triangle. If I come right down the middle of this triangle, that is also just a radius. So this is a radius, and the height is also a radius. So this is also a radius. So when I get rid of that times sign, the area of a circle is pi r r, or pi r squared. And so that's where the area of a circle formula came from. So conjecture 71 can be added on with the area of a circle is pi times a radius squared, or pi r squared. Okay, the next one we're going to talk about is conjecture number 72, and this one is the area of a regular polygon. Now, a regular polygon means it has all sides equal and all angles equal. So I'm just going to do a regular hexagon because they're probably the easiest to draw. Here's kind of the center of that regular hexagon, so this regular polygon. Okay, what I'm going to do is I'm going to say, what if I go from that center and go to each vertex of the polygon. That creates a bunch of triangles. So I think the area of the regular polygon is equal to the area of one triangle times the number of triangles that I have in the polygon. Okay, I'm going to work on this a little bit. The area of one triangle is 1/2 times the base times the height. And then this is going to be times the number of triangles. Okay, so this is 1/2. Now let's go back and look at one of these triangles. So look at this guy right here. Right here is the base of that triangle. The base of that triangle is actually the length of a side of the polygon. Okay, so this is going to be times the length of a side times, okay, now I need a height. The height in here is a special name. It's called APOTHEM. The correct way to say it is apothem, with the accent mark on the A. Many students just call it an apothem. So it's kind of like an opossum or whatever, but they call it an apothem, but it's an apothem. So the fancy name for the height of a triangle, when I'm talking about a regular polygon, is an apothem. Okay, then times the number of triangles. Okay, let's go up here. If I have a 4-sided figure, I can get 4 triangles. If I have a 5-sided figure, I can have 5 triangles. In a 6-sided figure, I have 6 triangles. So this is actually going to be the number of sides. Okay, so now this is 1/2. The length of a side we abbreviate with an S. The apothem is an A, and the number of sides is N. So the formula for the area of a regular polygon is 1/2 SAN. Now, if I take the length of a side, how long one of these sides would be, and multiply it times the number of sides, that would give me the perimeter. So another way to write it is 1/2 AP, because S times N actually turns into that P. Now, I don't use that real often. I usually use this. But if they are talking about a perimeter, they give you the length of the perimeter, well, then definitely use that form of the formula. So those are the 2 formulas that we were going to do today, the area of a circle and the area of a regular polygon.